Greetings everyone, I am Zarin Mesbah from Group 9 of SMBE 3033. Today we are going to introduce our topic of our microprocessor project to you, which is the leakage current tester. A very thanks goes to our lecturer, Dr. Arief, for giving us this wonderful opportunity to present our topic. Let me introduce my team members to you. First, we have YAHYA Mohammed SINJAB, and then we have ZHENG PENGFEI, and together we are going to present today's topic. So let's start with our project background. So what is leakage current? It is a highly fatal problem affecting workers, patients, and many consumers of electrical appliances throughout the world. As you can see, a large number of families loses their loved ones because of this one technical fault. Electric shocks can range from very mild to lethal, and it is one of the leading causes of death of workers in the industries. It can happen because of short circuits inside wires, improperly installed electrical equipments, or because of using damaged electrical components. It can also happen due to lack of corrective maintenance of appliances. Victims can easily be shocked if they get in contact with such equipments with an energized power sources. Let's move on to our project motivation. Leakage current is a serious issue to be taken care of. Here, as you can observe, some of the important issues are discussed. First of all, electronics are widely used these days, and not just in industries and households, but most of the time, medical equipments are also electrical devices. Since it is not something that can be easily detected, faults in these may even lead to more injuries to the patient. Not just patients, but every single workers in the industries deserves for their safety to be ensured. So here are the project objectives for the device that we are going to make. It is a leakage current tester that is going to determine whether the equipment has a current leakage problem, to define the users of the leakage current index, and also to record the detailed information inside the device through the storage system so that the user can distinguish. Our target users are companies manufacturing electrical devices, medical workers like nurses, doctors, and other technicians, electrical workers, and laboratories dealing with electrical equipments.
Hello, this is Yahya, and now I will be talking about chapter 2 of our project, which is about the project methodology. Let's start with the project flowchart and let's define the flowchart. Well, the flowchart is a graphical aid that is designed or created to visualize the processes and the steps that the project will go through. And our project consists of 10 steps, starting with finding a problem to solve, studying and analyzing the problem, finding a solution, making the proposal, preparation for the presentation, sketching and designing, hardware specifications and design, coding, final report, and finally submitting the final report. Secondly, the task delegation. Since we are a group, we should work as a group. Since there are some groups that each member work individually, and this is a very important issue. So, to make sure that we work as a group, we distributed the tasks equally. We make sure that each member work on the 4 chapters, and each member used his strength points in the task that he was given. Lastly, budgeting. Each project needs a budget since there will be some costs. And our project has 2 types of cost. The first type of cost is going to the products or the electronic elements that we use to design or to produce our product, such as the LCD screen, the current sensor, LED lights, and so on. And the total cost of the electronic element was 68 ringgit. The second type of cost, which is the services cost, such as the product development cost, which costed us 50 ringgit. Another example is the cost of labor, which costed us 100 ringgit. So if we combine the product development cost, the components cost, the labor costs, and the desired profit, which means the profit that we will get from selling this product, the required selling price is going to be 297 ringgit, almost 300 ringgit. Thank you.
Hi, I am PENGFEI. I will talk about the chapter 3. Proposed project design. For this chapter, we have 5 parts. The first one is block diagram. The second one is components diagram. The third one is system workflow. The first one is instrument for input parameter. And the last one is back-end digital processing design and development. At the first, I will talk about the block diagram. As you can see, this is our block diagram. The first one is input current sensor, and then its process. Measure the current from the input value. If we get the input value, we will check for the threshold. If above the threshold, then turn a light on. And then is our output, turn on or off LED based on the current value. All of this is our block diagram. And then I will introduce the components diagram. As you can see, in the medium is the Amiga 328, and we also have the current sensor, resistor, power supply, capacitor, and we also have the LCD to display our current value. We also use the LED and buzzer to let the user know if the equipment leakage current or not. And then is our system workflow. The first is our system start, and then we'll define the threshold value. And then we'll get the value from the current sensor ACS712, and then convert the value into current value using the formula, and then we'll determine the current value and the threshold. If the current value above the threshold, we'll turn on the LED and go to the end. If the current value is not above the threshold, they will turn off the LED and go to the end. All of them is the system workflow. And then is our instrument for the input parameter. As you can see, the picture is the current measurement sensor. As this parameter, we are using ACS712 current sensor, which is available in 3 different settings with the different current ranges. We can see the table. And then we are using a 5A current sensor, which can be used to measure the different current ranges. ACS712 is a Hall effect-based current sensor. For input, we need to cut the wire and place its both ends into 2 input circuits. We need to supply the VCC and ground from the microcontroller Amiga 328, then using the ADC to be able to read the sensor value. As one, we can see from the table, for our modular sensitivity range is 185. That means for 1A change, it will generate 185 change in the output voltage. Now, to convert this output voltage into current value, we will use this formula. Current value equal to offset minus read value multiply ADC resolution divided sensitivity of the modular. The read value equal to a NIGO value that was read from a NIGO pin. ADC resolution equal to used to convert read value into voltage, and then sensitivity of the modular equal to 185, and the offset equal to output voltage value when there is no current is following. And for the only unipolar current, the VCC as shown. That's all for the instrument for input parameter. As the last, I will talk about the back-end digital processing design and development. The first is also over system start and intelligence ADC sensor and threshold value, and then read the ADC value and using formula convert it into current value, and then also determine the current value is above or not threshold. If the current value above the threshold will turn on the LED, go to the end. If the current value is not above the threshold, will turn off the LED, go to the end. All of this is about the chapter 3. Thank you.
So in conclusion, we can say that our leakage current tester, which can detect whether there is a leakage hazard in a medical device or in any other electronic equipment, can help to avoid unwanted situations and accidents, saving people from further catastrophe. In the long run, we also plan to modify our tester by improving it so that it can become more efficient in ensuring maximum safety of the consumers. Thank you so much for staying with us and watching our video.